Hello everyone, good morning to all of you. Today I am going to discuss the last topic in the first module, that is the quadratic form. So let them start with the definition. A homogeneous polynomial of the second degree in any number of variables is called a quadratic form. The quadratic form Q can be generally represented as Q is x transpose Ax. Here x is x1, the variables x1, x2, etc. up to xn, and you have a matrix A, that is an n by n matrix, just like a11, a12, etc. 1n, and an1, an2, etc. ann, and the last column is x1, x2, etc. up to xn. All of you, when you multiply these three, we get an equation just like a11 x1 square plus a12 x1 x2, a13 x1 x3 plus etc. plus a11 x1 xn plus a21 x2 x1 plus a22 x2 square plus etc. plus a2n x2 xn and plus etc. plus generally it is an1 xn x1, an2 xn x2 plus etc. plus ann xn square. That means every homogeneous polynomial of the second degree, if your variable is a 2 variable or in a 3 variable, definitely it will not affect the degree of this homogeneous polynomial. That's why it is called a quadratic form. For example, if we are replacing x is equal to x1 x2, here quadratic form Q is just like x transpose Ax, that is x1 x2. Here there is only 2 variables, a11, a12, a21, a22. Just simply it is a 2 by 2 matrices because of the existence of 2 variables, x1 x2. The product is just like a11 x1 square plus a12 x1 x2 plus a21 x2 x1 plus a22 x2 square. That is, if your variable is a 2 variable, definitely it is a square second degree polynomial. That's why it is called a quadratic form. If you generally, if your variable is 2 variable or in a 3 variable, no problem, whatever it is, it does not depends on what. If any number of variables, you are required getting homogeneous polynomial having a degree 2. That's why it is called a quadratic form. So in the next section, your problems are first types of problems in your material is they given a quadratic form just like this. So reversely, we want to find the matrices. Just in your syllabus only they have given the problems in 2 variables and 3 variables. Now I am going to discuss these two problems in 2 variables and 3 variables for computation of the matrices from the given quadratic form Q. So the first question, find the matrix associated with the quadratic form. First question Q is 4x1 square plus 12x1 x2 plus 13x2 square. And to the second question, your quadratic form is minus 3x1 square plus 4x1 x2 minus x2 square plus 2x1 x3 minus 5x3 square. The problem is, so they given a quadratic form. All of you know the general form of the quadratic form Q is what? Q is just x transpose Ax. So the process is here how to compute the matrix A. This is the question. They given the quadratic form, how to get the matrix A. All of you know the first question, how many variables here? The only variables are x1 and x2. So definitely all of you know in the first question your Q is what? This to be given Q is 4x1 square plus 12x1 x2 plus 13x2 square. Then definitely all of you know it is just like x1, x2 because of the 2 variables. And you have a matrix A. Definitely it's a 2 by 2 matrices, that is a11, a12, a21, a22, and here is x1, x2. What is our aim? Our aim is how we can find out this matrix A. So this matrix is, can you say this is x transpose Ax? What is our aim? The first question is how we can identify the matrix A. They given this quadratic form. It is very simple. The way is, listen here, if your matrix is definitely it is 2 by 2 matrices. Definitely it is 2 by 2 matrices, all of you know that. So can you imagine here is x and y, sorry, x1, x2, and here also x1, x2, just a tricky method. So x1 square, what is the coefficient of x1 square here? Coefficient of x1 square is 4, so mark here is 4. Here it is x2 into x2, what is x2 into x2? All of you know it is x2 square. What is the coefficient of x2 square? It is 13. And here is x1, x2. And here is x2, x1, but here there is only one entry, that is 12 x1, x2. So take the half of this coefficient and substituting here and here, that is the way. So all of you know the coefficient of x1, x2 is what here? 12. So take the half of 12 and put that values here and here. This is the matrix associated with the quadratic form, because can you imagine this 12x1, x2 is just like 6x1, x2 plus 6x2, x1. So, and according to that, assumption, we get the matrix A as 4, 6 and 6, 3. This is the matrix associated with the quadratic form of the first question. And then I move to a second question. In the second question, your quadratic form is minus 3x1 square plus 4x1 x2 minus x2 square plus 2x1 x3 minus 5x3 square. So all of you know, in this particular quadratic form there are only 3 variables x1, x2, x3. Definitely it is of the form sum x1, x2, x3 into, you have a matrix A. All of you know that the order of that matrix is 3 by 3, that is A11, A12, A13, A21, A22, A23, A31, A32 and A33 of, this is here is x1, x2, x3. You can call this by some x transpose AX. So what is our aim? How to identify this matrix A? This is the question. So here the matrix A is, it is very simple. So imagine here is x1, x2, x3 because of 3 by 3 variables. Here also x1, x2, x3 and take the product. What is x1 square? The coefficient of x1 square is minus 3. So mark here minus 3 and coefficients of x1, x2 is what? x1, x2. Here is the coefficient of x1, x2 is 4. Because of the existence of x1, x2 and x2, x1, take the half of 4 and add here and here. This is 2 and 2. Place here and here. This is the step. And here is x1, x3. This is the coefficient of x1, x3. Since the occurrence of x1, x3 and x3, x1, take the half of the coefficient of 2 and place here and here. This is the 1 and 1. And x2 square. So here is 1 and only 1 x2 square. There is no term in x2 square. So here is x2 square. So the coefficient of x2 square is minus 1 here. So place here minus 1. And x2, x3. Where is x2, x3? There is no such term here. So x2, x3. So place 0 and 0 here. And x3 square. What is x3 square? The coefficient of x3 square is, all of you know, it is minus 5. So this here is minus 5. So this is the matrix associated with this quadratic form. From the example 1 and 2, definitely all of you know what is the property of this matrix A. Every time A transpose is same as what? A. That is, the matrix obtained from every quadratic form, which is a 2 by 2 or 3 by 3, always it is symmetric. So a matrix associated with every quadratic form is symmetric. That's our conclusion. That is one of the notes. Okay. Then all of you know the way of finding the matrix associated with every quadratic form. The next section is the nature of the quadratic form. There are 5 kinds of natures. The first one, the quadratic form is positive definite if and only if all the eigenvalues of the matrix associated with the Q are positive. If we get all the eigenvalues, all of you know the way of computation of the matrices and all of you know how to computing the eigenvalues as it is to be studied earlier. So just computing all the eigenvalues of your corresponding matrices of the quadratic form, and if all the eigenvalues are positive eigenvalues, your quadratic form is positive definite. If all the eigenvalues are negatives, then your quadratic form is, you say your quadratic form is negative definite. And if all the eigenvalues are greater than or equal to 0 and at least one of them is 0, then we say your quadratic form is positive semi-definite. And next is negative semi-definite. Like on the same manner, if all the eigenvalues of the matrix are negative numbers and at least one of them is 0, then we say your quadratic form is negative semi-definite. And one more kind here is indefinite. That means your associative matrix have some positive eigenvalues and minus negative eigenvalues in a mixed manner. Then that cases you may say your quadratic form Q is indefinite. So listen here, so there are only 5 kinds of natures of every quadratic form. It is positive definite or negative definite or positive semi-definite or negative semi-definite or indefinite. I will discuss this by using some examples. Look, the first example, determine the nature of the quadratic form Q is 2x1 x2 plus 2x1 x3 plus 2x2 x3. All of you know how to write the matrix associated with this quadratic form. Here there is only 3 variables because x1, x2 and x3 here. So the matrix is here So there is x1 square, no x2 square, no x3 square there. That's why the coefficient here is completely 0. And here is x1, x2 is 2. That's why here is 1 and 1. And x1, x3 is 2. Here, that's why take the half of here. That is here and 1 and 1. And the coefficient of x2, x3 is 2 here. So here is 1 and 1. So definitely this is the matrix associated with this quadratic form. This is a symmetric matrices. Then all of you know how any matrices is to be given, how to computing the eigenvalues. For that purpose, first we computing the characteristic equation. Already we studied about in a normal way or in a shortcut method for computing the eigenvalues of a characteristic equations of a given matrix. It is all of you know what is this, determinant of a minus lambda equal to 0. That's why, so we get an equation just like a lambda cube minus 3 lambda minus 2. Try to do that. Definitely this lambda cube minus 3 lambda minus 2 is 0. On solving this cube degree equation, there are only 3 roots, that is 2, minus 1 and minus 1. Then whatever your conclusion. Here in this particular example or in a particular question, your eigenvalues are, some eigenvalues are positive and some are negative. That's why your conclusion that your quadratic form is indefinite. I'll discuss one more example. Determine the nature of the quadratic form. Q is x1 square plus 4x2 square plus x3 square minus 4x1 x2 plus 2x1 x3 minus 4x2 x3. Look here, the coefficient of x1 square. First step is what? How I write the matrix associated with this quadratic form. Here the matrix is x1 square. Take the coefficient of x1 square is 1 here, x2 square is 4 here, x3 square is 1 here. And here x1 x2 coefficient is minus 4. So take the half. It is minus 2, put here and here, minus 2 and minus 2. And x1, x3 is, the coefficient is 2, so place here 1 and 1. And x2, x3 is minus 4, so place here minus 2 and minus 2. So this is the matrix associated with this quadratic form. And from this matrix, here also the same procedure. You may continue with the characteristic equation. All of you know how to computing that. The characteristic equation of this associated matrix is, all of you know, just lambda cube minus 6 lambda square equal to 0. On solving this, we can get the lambda values as are 0, 0 and 6. Then what is your conclusion? Here, the eigenvalues are, two values are zeros and one of them is positive. That means all eigenvalues are greater than or equal to 0 and at least one of them is 0. So what is your conclusion? Your quadratic form is positive, semi-definite. Positive, semi-definite. Likewise, there are several questions in your material. So determine the nature of these 5 categories. Okay. The one of the important question in this section is canonical form or principal axis form of the quadratic form. So this is a very important section. So the problem is, what kind of conic section is represented by the quadratic form q equal to 7x1 square plus 6x1 x2 plus 7x2 square equal to 200 represents. Transform it into canonical form. Express x transpose equal to x1 x2 in terms of the new coordinate vector y transpose is y1 y2. So it is a very important question. The way is, all of you know this is the given quadratic form. What is the given quadratic form? Q is 7x1 square plus 6x1 x2 plus 7x2 square. So that's why you know the matrix associated with this quadratic form is 7x1 square and 7x2 square and 6x1 x2. That's why here the coefficient is 3 and 3. So it is a symmetric matrix, that is always symmetric. So no need of explaining this way of obtaining the eigenvalues. All of you know that. The characteristic, write the characteristic equation of this matrix A and find out the eigenvalues. Here we get the eigenvalues are 4 and 10. If you have any doubt, try to do that. If you get the eigenvalues that lambda is 4 and 10. So, but here is no such question. Can you say what is the nature of this quadratic form? Since all the eigenvalues are positive, all of you know the nature of the quadratic form is positive, definite. But actually there is no such question here, no problem. Next is, for after getting the eigenvalues of the matrices, you must computing the eigenvector corresponds to each of the eigenvalues. So already we have discussed it earlier, because in the previous section we have to be studied up to diagonalization, and on the previous section we studied eigenvalues and eigenvectors computation. So the eigenvector corresponds to lambda equal to 4. You compute that. So we get x1 is, this is the eigenvector corresponds to lambda equal to 4, that is 1 and minus 1. Next is, you can computing the eigenvector corresponds to lambda equal to 10. And if we get the solution as x2 is 1 and 1, from the eigenvectors, all of you know the way of writing the model matrix B. B is x1 x2. It used to be studied in the previous session for diagonalization. For getting the last step in the diagonalization, this is the way. We want to create the model matrix B. The model matrix B is x1 x2. Here is x1 is 1 minus 1 and x2 is 1 1. And look the question. In this question, your problem is express this quadratic forms to which form? Canonical form. After that, you can identify this quadratic form is what types of conics this represents. The way is, after writing the model matrix B, we want to write the matrix of transformation. The matrix of transformation, what is that? Actually, all of you know the given quadratic form can be converted in new form. That form is called a canonical form or principal axis form. For converting that purposes, we use a matrix. That matrix is called a matrix of transformation. So, the matrix of transformation used for that is, I can call that by P. P is, sometimes it is called normalized eigenvectors, normalized model matrix. It is called a normalized model matrix. So, after computing the model matrix, we want to compute the normalized model matrix. So, that is called the matrix of transformation. That P is, you can call this by B cap. It is just x1 cap and x2 cap. So, I will explain how to write the x1 cap and x2 cap. x1 cap is nothing but, all of you know x1 cap is x1 by norm x1 or modulus of x1. What is here x1? All of you know the vector x1 is here is what? 1 minus 1. So, this is the vector 1 minus 1. And what is the modulus? Modulus is nothing but it is root of this 1 square plus this minus 1 square. So, all of you know this is equal to what? 1 minus 1 divided by root 2, that is equal to 1 by root 2 minus 1 by root 2. Like way, so here we get the matrix, the model matrix, the normalized model matrix P as x1 cap, x2 cap, that is 1 by root 2 minus 1 by root 2. So, since you know x2 is this one, 1 and 1, so the normalized eigenvector, what is x2 cap? This 1 by root of 1 square plus 1 square, that is 1 by root 2. Here is 1 by root of 1 square plus 1 square, that is again 1 by root 2. So, here we get x2 cap as 1 by root 2, once again 1 by root 2. So, this is the matrix used for this transformation. That is, we want to transform this given quadratic forms to a new form, that is canonical form or principal axis form. This is just a transformation. So, the matrix used for this transformation is normalized model matrix. We want to compute that, that is this P. So, definitely what is this P? This is P is an orthogonal matrix. Definitely this P is an orthogonal matrix. Orthogonal matrix. All of you know orthogonal matrix. All of you know the definition of an orthogonal matrices. What is orthogonal matrices? A into or P into P transpose is identity. So, every time after the model matrix B, we must create a normalized model matrix. It is always orthogonal matrices. So, this is an orthogonal matrices that can be used for the conversion of the given quadratic forms to this forms to canonical form or principal axis form. Next is, this is the matrix of transformation. Next one is, what is the orthogonal transformation? The orthogonal transformation used for this reduction. Reduction means just converting the given forms to a new form, that is principal axis form or canonical form is x is equal to py. This is the orthogonal transformation used for this purpose. So, all of you know what is x here is x1 x2 and what is p here. So, this p is the matrix 1 by root 2 minus 1 by root 2. Once again here is 1 by root 2, here is 1 by root 2. Here is y, can you imagine y as y1, y2. So, which implies we get x1 is 1 by root 2 y1 plus 1 by root 2 y2 and x2 is 1 by minus 1 by root 2 y1 plus 1 by root 2 y2. This is the conversion. That is, if we use the orthogonal transformation as x is equal to py, then definitely we get x1 in terms of y1 and y2 and x2 in terms of y1 and y2. This is the this question asked. What is this question? Express your x transpose x1 x2 in terms of the new coordinate vector y1 and y2, that is to be here. express this x1 in terms of y1 and y2 and x2 in terms of y1 and y2. Then all of you know what is the given quadratic form. The given quadratic form completely a variable in x1 and x2. All of you know that. If we replacing x1 by 1 by root 2 y1 plus 1 by root 2 y2 here, and x2 by minus 1 by root 2 y1 plus 1 by root 2 y2 here, definitely all of you know this quadratic form in terms of y1 and y2. Okay. So the way is, if we replacing, can you imagine if we put x1 is 1 by root 2 y1 plus 1 by root 2 y2 and x2 is minus 1 by root 2 y1 plus 1 by root 2 y2. So we get your given quadratic forms q as if you replacing x1 by this and x2 by this, here definitely this q in terms of y1 and y2, that q is lambda 1 y1 square plus lambda 2 y2 square. Every time this is lambda 1 y1 square plus lambda 2 y2 square. I will explain the way of writing this. No need of substituting that, because all of you know the reason. Listen here. The way is, all of you know your quadratic form q is what? X transpose Ax. Okay. What is x? X can be py here. So here is py. This is the transformation py transpose Ax. What is this? It is y transpose p transpose Ax. A into what is x? X is py. All of you know that. So y transpose p transpose, or we know AB the whole transpose is b transpose A transpose. So y transpose p transpose A into py. So what is p transpose? Your matrix is P is an orthogonal matrices. So P transpose is identity. We also know what is P inverse. P inverse is every time identity. That means your transpose matrix of P and inverse matrix of P are equal. So P transpose is same as what? P inverse. So that's why replacing this P transpose by P inverse. So it is Y transpose P inverse AP. This is possible only when Y. Your matrix is an orthogonal matrices into Y. It is this P inverse AP. It is the diagonal form D. That's why it is Y transpose dy. Okay. So what is the D? You know D is what? Look here. You know D is what? This Q is equal to what? Y transpose. Just like Y1, Y2. Imagine. Just like Y1, Y2. Okay. D is lambda 1, 0, 0, lambda 2, because that's a diagonal matrix D. Here is y1, y2. What happened here? Every time it is lambda 1 y1 square plus lambda 2 y2 square. Okay. That's why I'll directly write this q as lambda 1 y1 square plus lambda 2 y2 square. Okay. So here, this form. So what is your lambda value? Lambda 1, all of you know lambda 1 value is 4 and lambda 2 value is 10 here. This q is becomes here 4. We'll raise this. So this q is 4 y1 square plus 10 y2 square. This form is called, this form is the reducible form of the given quadratic form. That form is called canonical form or principal axis form of this given quadratic form. This is the canonical form or principal axis form, corresponds to the given quadratic form. Okay. So one more question left here is, what kind of conic section is represented by this quadratic form and transforms it into canonical form? That is to be over. Express X transforms in terms of new variable y1 and y2. That is to be over. So one problem left here is, what kind of this conic section this represents? Okay. So in the given question, they given the value of this quadratic form is 200. Correct? The given quadratic form is 200. That's why the reducible form of this quadratic form also have the same value. So since q equal to 200, it is to be given in the question. That's why we get 4 y1 square plus 10 y2 square is 200. That is y1 square by 50 plus y2 square by 20 equal to 1. Okay, what is this? All of you know x square by a square plus y square by b square is 1. What is this? It is an ellipse. Okay. So the conic is, what is the conic here? The conic is ellipse. Suppose here is minus. What's your conclusion? Imagine the conic is x square by a square minus y square by b square is 1. The image, what is that? it is hyperbola. Suppose you can imagine here is 0. What is that? It is the pair of straight lines. So there are 3 types of conics in your, so many problems, but in your syllabus there are only 3 kinds of questions. So this is the problem here. What types of conic section is represented by this quadratic form? Suppose, can you imagine the situation? Suppose in this given problem, they are not given this question. Express X transpose not given. Can you imagine? Here there is no such problems. The problem is just like that. What kind of conic section is represented by this quadratic form and transforms it into canonical form? So you must start from this, find out the eigenvalues and no need of computing the eigenvectors. After getting the eigenvalues, all of you know the direct way of writing what? Direct way of writing the canonical form. You write it, no problem, because here there is no questions, just like the express X in terms of y1 and y2. If they are given just like that, you may continue up to there. Otherwise, no need of that. Just directly write the quadratic form, the canonical form, and identify the conic by just equating that to 200. Okay. Okay. Write the canonical form of the quadratic form Q is 2x1 x2 2x1 x3 plus 2x2 x3. Second question, Q is 3x1 square plus 5x2 square plus 3x3 square minus 2x1 x2 plus 2x1 x3 minus 2x2 x3. Also find the nature, rank, index and signature. These are some terminologies. We'll discuss all the terminologies by using some examples. So in the first question, so this is a given quadratic form Q is 2x1 x2 plus 2x1 x3 plus 2x2 x3. All of you know the way of writing the matrix associated with this quadratic form, and also we know how to write the characteristic equation and how to computing the eigenvalues of any matrices. This is a 3 by 3 matrices. That's why you have 3 eigenvalues. So after you compute your own way, definitely the eigenvalues are 2, minus 1 and minus 1. Already I discussed the canonical form or principal axis form in the previous question. So the canonical form or principal axis form is, since the occurrence of 3 eigenvalues is here, so the canonical form or principal axis form of this given quadratic form is lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square, that is 2 y1 square minus 1 y2 square minus 1 y3 square. This is the canonical form or principal axis form of the given quadratic form. So that section is to be over in the first question. Next is find the nature. All of you studied about it earlier. Since here what are the eigenvalues? Here the eigenvalues are 2 and 2 are negative. What is your conclusion? Some eigenvalues are positive, some eigenvalues are negative. That's your conclusion. That what is the nature? Nature is Q is indefinite of this particular example. Okay. Next is what is rank? It is quite different from the rank of the given matrices. This is rank of the quadratic form. Rank, index and signature. So rank is equal to number of terms in the canonical form. This is the definition. Number of terms in canonical form. So in this question, how many terms in the canonical form? 1, 2 and 3. So the rank is 3. And index is number of positive terms in the canonical form. Number of positive terms in canonical form. This is the definition. How many positive terms here? Only one term, that is index is 1. Signature is number of positive terms minus number of negative terms in canonical form. That's why the index signature of this question is number of positive terms is 1 and number of negative terms is minus 2. So the index signature is minus 1. So this is the rank of the quadratic form, not rank of a matrix, index and signature. Look the second example. So this is a second example. Q is 3x1 square plus 5x2 square plus 3x3 square minus 2x1 x2, 2x1 x3 minus 2x2 x3. So you know the way of writing the matrix and you know the computation of eigenvalues. Here we get the eigenvalues are 2, 3, 6. So definitely what is nature? Nature is very simple. Since all the eigenvalues are positive numbers, your nature is what? Q is positive definite. All the eigenvalues are positive. The nature of the quadratic form is positive definite. Okay, so the canonical form or principal axis form is what? Since the lambda 1, lambda 2, lambda 3, 3 lambda values is, so Q is lambda 1 by 1 square plus lambda 2 by 2 square plus lambda 3 by 3 square. Here is lambda 1 2, lambda 2 3 and lambda 3 6. So it is 2 by 1 square plus 3 by 2 square plus 6 by 3 square. This is the canonical form or principal axis form of this corresponding quadratic form. So now there are 3 questions left here is what is rank, index and signature. Rank is equal to what? Number of terms in the quadratic form, canonical form, 3. Index is what? Number of positive terms in the canonical form, 3. Signature is what? Number of positive terms minus number of negative terms. Here 3 positive terms but no negative terms. So, so signature is also 3. Okay, thank you.